All right, today we're going to look at section 2.6. We're going to look at scatter plots and lines of best fit. In a bit. So, what is a scatter plot? It's a graph of data points that shows the relationship between the two data sets. So, we're going to look into that. We're going to do some examples of that. It can just simply be an XY table, or it can be some data from the real world that you collected, and you want to look at a visual representation of it. So, the scatter plot is a graph. We'll be looking at linear associations, but others exist and will be shown at a later date. So we're focusing on our linear relationships at this time. The relationship can have a positive correlation, a negative correlation, or no correlation. If I have a bunch of dots that kind of go in an upward trend, like so, we would say this would have a positive correlation. If we have data points that kind of come down in a negative looking sense, this is a negative correlation. And if the dots are just scattered all over the place and seemingly no kind of pattern whatsoever, we would classify that as a no correlation. Data sets that have a form of correlation, we ask if there is a line that best represents the data. And if there is, how strong of a correlation is it? So in this example looking right here, you can see that this looks almost very similar to a line, and so does this one. So we want to see if there's a line that can best represent this data, how good of a relationship or correlation would it have to that line? Same thing here. And so that is called the line of best fit. We're going to use a linear regression technique to help us find this. We're going to use the calculator to help us find this line. You can find any line just simply doing your best estimate of where that line would best represent this. And usually what we do is we just kind of think of the dots as you're going to draw a line, and that the dots are going to be kind of balanced around that line. Okay, kind of like a teeter-totter. You're going to have same dots on both sides of the line. The line does not have to go through any particular point in the data set. It doesn't have to go through any point in the data set. It is just a line that looks like it represents a balance between all the dots that are there. That's called the line of best fit. And the calculator will be used to determine this. You can do it by hand, but it takes a lot of work, and we're going to use the calculator, which is much quicker. As we go through this, you're going to be asked to find what's called the correlation coefficient. And this number, which is represented by the letter lowercase r, is used to determine how closely the data fits the line of best fit. R is going to be a value between -1 and +1. R equals 0 means that there is absolutely no correlation. If R is 1, then you have a perfect positive correlation. And if R is -1, then you have a perfect negative correlation. Very rarely are you going to get those. So what we do is the closer this absolute value is to 1 is, the better the correlation is. So if I have a data number correlation coefficient of 0.2, then that's closer to 0, so we would say it has no correlation. If I have a coefficient that is 0.98, that's very close to 1, so we would say that has a positive correlation. We're going to use the calculator to find the line of best fit and the correlation coefficient. Once we've looked at the line of best fit, we can use it to interpolate or extrapolate information from that might be in our table. What is interpolation and extrapolation? The line of best fit would be a model of all the data. So interpolation means that we're going to use the model or line of best fit to estimate a value within the range of the known values. So when you make a table, you have the top number and the bottom number. So anytime we pick a number, we want to find something that's not in the table, But in between those values, that's interpolation. Extrapolation means we're going to use the model to estimate a value that is outside values of the table. So if the last entry in your table is x is 15, I might ask you to tell me what the y value would be when x is 20. So it's outside the range of my table. And I'm going to show you how to do all that kind of stuff. Causation describes a cause and effect relationship. A change in one variable causes a change in the other variable. And then here's a key concept right here. Correlation does not imply causation. Just because you gathered two pieces of information and you drew them out and you got some kind of data points that line up like this does not necessarily mean that there is a relationship, that a causation between the two. And we'll talk more about that. Could be something along the lines of the number of dogs in a park tied to your favorite ice cream. That has nothing. I mean, you can lay out a table and you can show that you have a positive correlation in that, but there's no relationship really that's a causation or cause and effect of the number of dogs in a dog park to the number of ice creams you eat in a year. They're just not going to happen in that sense. So let's look at a couple of examples that you might be asked to do. So in your textbook on page 123, there's a problem that they want us to do. Get to that real quick. And it is problem number 8. I'm going to show you the textbook for problem number 8. I will zoom in so you can see it. So this table right here shows the hours of studying, which they represent as X, and a person's test scores, which they represent with the variable Y. What is the equation of a trend line that models the data? What does the slope of your trend line represent? Okay, so this right here is, we're going to draw a scatter plot to represent it, and then I'll show you the rest of it. So taking that data right there, let's go and graph this information out. I'll reproduce that table real quick. So down here, I'll put the table X and Y. We have 6 and 77, 7 and 80, 7 and 83, 8 and 87, and 9 and 92. So we're going to put dots on our graph. 6 and 77. That's 75, 77 is about there. 7 is 88. At 7, we have an 88. And we have an 83. At 8, we have an 87. Just shy there. And at 9, we have a 92, which is somewhere right about there. So there's our data. These look pretty straightforward. This one's out of place there. And so what they were asking for is a trend line. A trend line is you grabbing your ruler and trying to balance out a line between all these dots. Because of that one that's kind of out of place there, I don't want to go right through these. I want to kind of try and balance it out. I have more on this side than I have on that. So I usually kind of think of it as like weights. If this one weighs here and these weigh a certain amount, how do I balance this so that it's perfectly balanced like a teeter-totter? And so you just do your best and just find any line that you think works. You can come probably somewhere right about there. And that could be a trend line right there. Okay, it may not be the best one, but it is one. And that's all they ask you to do. And then what you can do is you can actually then draw this line out using your pencil. You just draw this line. Oops, let out. Draw it all the way through so it hits at least the y-axis. And so that is a trend line. You can then find the equation of this line. The line is separate from the data points. Notice my line did not go through any of the data points, but I can still find the equation of this line by simply finding a point that's on this line. It looks like this is a good point right here. And then we got to find another one to find the slope. Just any other point would be fine. Looks like it goes to that point right there. And so I have a rise of 10 and a run of 2. So my change in y over my change in x would be 10 over 2, or 5. My point of intersection, that's the point I can use, would be 0, 50. And so then I can use the point slope formula. X minus 0. And then cleaning all this up, and I get y equals 5x plus 50. So there's an equation of a trend line of that right there. When you do a table of scatter plot, please make sure you write the titles. I didn't do that down here yet, but the X values are hours of study, and this over here is your test score. You want to make sure you title it with your axes so that we know what they represent. For the actual line of best fit, I'm going to show you on this one. It is a calculator activity. Turn on your calculator, go to this page right here, start a new document. Do not save. You never save any of the documents. And then what we want to do is we're going to add a list, which is number 4. Number 4, add lists and spreadsheets. So I click on that, I get this table right here. To do your table properly, you need to put titles up here for your columns. Keep it simple. I always use, for this column A, I go down here to the alphabet part, and I just pick 4 A's. So I just type 4 A's. Not 2, but 4. Come down out of there, go across to the B column for your X's, and don't use X's and Y's because those have other meanings. And just put 4 B's. And so that you know that column A is A's, that's your X column, your input, and B is your output. Let me see if I put it right here and you can still see it. I'm going to type in these values into the X column, the A column. 6, and you hit enter after each entry. 7, 7, 8, and then 9. And then I'm going to go across and I'm going to put in the Y values that go with those. 77, 88, 83, 87, 92. So double check to make sure your list is accurate. I got that glare above me. Okay. Check all your data points real quickly. And then once you have this, you're ready to go. You're going to push the menu button. You're going to go down to number 4, statistics. And you're going to do stats calculation, which is number 1. And these are all the different regressions that pop up. Okay. We are going to do what's called the linear regression. And we're going to do the mx plus b one, linear regression, mx plus b. And what that means is it's going to give me the y-intercept is the b, and the slope or rate of change is the m. Select it. You can hit enter. And this pops up. You have an X list and a Y list. The X list, you need to change from what's defaulted there. Use the side arrow to get the drop-down menu and pick your A's. You can tab to the next line. So select the drop-down menu, select B. So there's your X's and Y's. You can tab out all the way down, leave all the rest of the things there. It's going to start my entries in this column, the data that we're going to use, and it's usually the next column over, which in this case is C. Once I get to that, go to OK, select enter, and there it is. This is the equation model you're using, mx plus b, and then underneath it, they will tell you what m is, they will tell you what b is, And then right down here, they will tell you your R, the correlation coefficient, right there. So the data that might be a little hard to read is this. This is what they have, and you put it into the format. So the line of best fit is, and we round to 3 decimal places, 4.462x plus 52.385. This right here is the line of best fit. It is the best line to represent that data. This was my estimate for this line. You can see I'm not that far off, but this is the best one with the calculator. And the R we get is 0.895. Again, round to 3 decimal places. So that's a pretty good correlation. Anything with at 0.9 and higher obviously is better, but that's not that bad. There's your line of best fit. And the video, there's a video in your Google Classroom about how to go about finding this right here on the calculator, or you can pull off the steps that I just showed you right there. There's one more question I want to look at, and that's on page 133. Again, they want us to use technology to find the linear regression, so here's another example that I've done. I'll go through it one more time. I will start a new document, number 4, and do the exact same thing again. AAA. Oops. See how I use that? Look at it. See how it's a little bit different this time? How it's boldface. That means I've already used that letters. So I'm going to exit out of this, not use that. I'm going to start a new document. And the reason it was is because I kept the other one in there. And so now when I do it, it'll be okay with it because I deleted the other one. It's gone. We're going to put this data in. So I have 12, 14, 16, 18, 20. Go across and put in the Y values that go with those. 35, 39, 41, 44, 48. Once you got all your data in there, menu, stats, stat calculations, linear regression, MX plus B. Put in the new data, and this one is B. Tab on down to the bottom. Let it just default to what it does. Hit OK. And there's our line again. So this line right here is going to be Y equals 1.55 M plus 16.6. There's your line of best fit for the data. And your R is 0.994. So you see it's a much better correlation than before. You can see that also here because of the fact that there's no continuing decimals. The next part of this question is this. Estimate Y when X is 19. Well, X is 19 is in between these two data points right here. Since there is no 19, I can't tell you what the value I would have gotten. So I have to use this line of best fit to interpolate that answer because 19 is between the two data outside edges. It's in this data set, and it's an interpolation. If I pick a value outside of 20 or below 12, then it's extrapolation. So all you have to do is you take your line and you simply plug in 19. And you find the Y value that goes with it. This is how it is done. I'm going to open up a new page so I can do this calculation on the calculator. Times 19. You can't see any of this. All right. 19 and then plus 16.6. If you take a look right there, hit Control Enter, gives me a decimal, and I get 46.05. I assumed it would be somewhere around 46. And this is what I got from the line of best fit. So these are the things they're going to be asking you to do. And so then we'll do more examples in class today.